Hello and welcome. In this tutorial, we'll have a look at the HALCON deep learning model and how data is organized within the model's workflow. With this knowledge, developing your own deep learning application will be quicker and easier. The HALCON deep learning model is a structure for different deep learning methods available in HALCON. As of HALCON 2005, it's available for classification, semantic segmentation, object detection, and anomaly detection. Thanks to their common framework, these methods share a lot of operators and procedures, and a workflow we recommend. Let's have a look at this workflow. The first step revolves around data acquisition and preparation. First, you need to acquire images of the machine vision problem you want to solve. As an example for this tutorial, let's consider this application. Our goal is to check the presence of these pills using object detection. This application is one of the standard HDevelop examples included with HALCON. After acquiring the images, we need to label them. Since the data needs to conform to model-specific parameters, like the image size and the gray value range, the images are then pre-processed. The next step is to train the deep learning model for your application. For this, HALCON includes several pre-trained networks that you can fine-tune with your labeled data. After training on your data, we need to evaluate the trained model to decide whether its performance is sufficient for your application. Once we're satisfied with the results, we can then apply the model on new images from a live camera feed. This is called inference. The first three steps are preparation before you can deploy the deep learning model on your machine. For all these steps, HALCON includes HDevelop example programs with extensive explanations and background information. If you prefer a more stripped-down approach with just the necessary operations, there are also examples that simply guide you through the workflow. For developing your own application, we highly recommend that you use these examples as a starting point and adapt them for your needs. Let's talk a bit about the training data and how it is processed throughout this workflow. The data is organized in a so-called DL dataset. This dictionary contains the directory where the images are located, the class names and their respective IDs, and the samples. Each sample dictionary initially contains the individual image file name and the labels. In this example, the labels consist of rectangle bounding box coordinates and respective class label IDs. To create a DL data set, we recommend labeling your data with the MVTec Deep Learning tool and then exporting the dataset from there. By the way, an important aspect of the dataset I haven't mentioned yet is splitting of the data. During the preparation of the data for training, the data is split into three subsets for training, validation, and testing. To assign samples to a certain split, a split key is set. Note that this complete data is still just meta-information. During the preprocessing step, DL samples are created that now directly contain the preprocessed images. The DL samples are written to disk and the file names are then also stored in the DL dataset. Note that for the inference, we need a DL sample as well. Here, it only contains the preprocessed image. As a result of the inference, we get another dictionary that contains, for example, the found instances. Don't panic if that seems a bit abstract. Our HDevelop example programs and the MVTec Deep Learning tool can guide you through the workflow without you having to worry about these details. What is important to remember is that, thanks to this open data structure, you can extend and adapt all HALCON deep learning methods completely according to your needs. This concludes this tutorial. Thank you for watching.